Hello, everybody. Hear me? Good morning. Thanks for joining us for our first webinar talking about construction sites' unseen energy drains. We've been working in construction for the last couple of years now, and we've picked up some insights that we'd love to share with you that may help with your carbon and energy reduction goals on site. So, hello, I'm James. I'm the head of sales for Measurable Energy. I've got a couple of guest speakers with me that I'm excited to introduce. So, firstly, we've got Adam Wright, my product director. He'll be jumping in and giving some insight around the technicalities of the technology that we provide. And then we've got Neil as well. Neil is one of our customers from Kier Construction. He's a senior environmental advisor who's been working closely with Measurable Energy across his sites in Scotland. So yes, we've got lots of stuff to tell you. We've only got 45 minutes, so we're going to keep it as short and succinct as possible. Let's start, shall we? I'm going to just talk about the agenda and a bit of housekeeping for you all. So the chat is live. Do chuck your questions in there as we go through. We're going to have some time, about 15 minutes at the end, to go through any questions that you have. So do put them in the chat. We are going to record the webinar. So if there's colleagues of yours that are interested in understanding the insights that we found, we will be circulating that after the call. So we've got 25 minutes to get through all of the juicy insights. We're going to go through three main, I suppose, key takeaways that we've found, and then we're going to do some Q&A at the end. All right, okie dokie. So let me set the scene a little bit first, okay? So this is a typical construction site. Well, I say typical, it's quite a tidy one. It can't be one of Neil's, because I've seen a couple of Neil's and they're not as tidy as this. Yeah, so let's just set the scene, right? You've got a construction site. On all sites, you've got some sort of site accommodation, whether it be welfare or site offices or a mixture of both. Within site accommodation, there are lots and lots of appliances that are drawing energy in hours and out of hours. So we've got lots of different things: heating and cooling units, lighting systems, office equipment, kitchen appliances, coffee machines, tea boilers, all of that good stuff. It will be interesting to know your thoughts on what you think is the biggest culprit for energy waste. Obviously, we'll be revealing that, and that might be an easy one to start with. So, yeah, like I say, we've got a site accommodation. Typically, you might see there's a couple of floors. On the ground floor, we've got a canteen and a welfare and a toilet area. And then the top floor might be an open plan office space with a few meeting rooms and a kitchenette. So there are wasted energy, well, there is wasted energy across all of this accommodation space. And we talk about plug power or small power. We've named it plug power, and we're not just referring to appliances that are plugged into plug sockets. We're also referring to heating and cooling. So anything that's on a fused spur, that counts towards plug power. And within the commercial offices, you might find that plug power represents about 40 to 50% of the energy use. Within site accommodation, this increases up to 95%. This is due to AC units and heating elements that typically in commercial offices are done using conventional heating methods, but within site accommodation, you see a lot of panel heaters and AC units that are controlled by fused spurs. So there's a lot of energy that we cover using our product. We also know from the couple of years of data that we've collected that half of this energy is wasted, and this is due to behaviours on site, but it's also due to out of hours consumption. So we've got heating and cooling units, we've got lighting systems. We don't touch the lighting, but that only accounts for about 5%. Within the accommodation space, you'll have drying rooms, and we'll be talking about drying rooms in a little bit. The reason that we focus a lot in site accommodation is we have the flexibility to control appliances at the device level. There are a lot of systems out there that work on a circuit level that they don't really have the flexibility to turn one thing off within a circuit and leave the rest on, which you missed out on savings. So we have the flexibility of doing that. And somebody who knows all about that is Neil. So I'm just going to invite Neil in now. So Neil, good to speak to you again. I just wanted to ask you a few questions around I suppose Kia's net zero ambitions and your reductions targets. We've got some stuff on screen, so if you just wanted to talk through that would be good.
Yeah, so with any kind of like tier 1 contractor, I think we've all got ambitious net zero targets, and they kind of go along with the kind of, I think it's plus 1.5 degrees net zero plan that the government's kind of putting out for. Regarding, I think it's like our plan by 2039 is to get net zero to our scope 1 and 2 emissions, and then overall with including net scope 3 by 2045. So yeah, it's going to be quite challenging, and kind of measurable energy hopefully will help us along the way.
Yeah, that's great. That's great, Neil. Yeah, obviously we've been working with you for the last 2 years now. But prior to us working with you across your projects, there was a big challenge, wasn't there, about firstly finding a solution to reduce this energy. And typically, years and years ago, you used to have a site agent going around and turning things off. So I just wondered if you could talk about the challenges you saw on site, especially around wasted energy and stuff being left on it in your sites. Could you tell me a little bit about that, Neil?
Yeah, so like Simon Kelly, who's kind of our lead in accommodation standards, etc., he went through quite a lot of kind of a process of going through different things, like different companies such as measurable.energy and other ones that I won't mention. To try and see what the best way of reducing our carbon and welfare is, because it's one of our, not obviously fuel, etc., will be our biggest carbon intensity thing. Yeah, Simon had said he went through all the kind of processes and stuff like that, and although maybe other companies can kind of save more on carbon, the measurable energy is like the most cost efficient one, I would say, and the easiest to implement.
Yeah, that's great, Neil. Yeah, I wanted to ask, when you go around your sites, where do you see the biggest? What is the biggest culprit for energy use and energy wastage?
Probably people just keeping monitors on, people keeping the drying rooms on, people keeping just things that they are not using, and those things can also stay on overnight. They stay on when they're not using them, and then obviously people working from home is becoming a big thing just now as well. So even half the desks in the office are kept on all day.
Yeah, that rings true with me. We see it all the time, and we had a project with Woodburn School, one of yours, Neil. And we did a case study on it, so we will share that in the chat so people can see it. But we found that out straight away after installing our tech. What we did is we put it everywhere. We put it in the drying rooms, we put it in the offices, and what we found is the drying rooms are just on 24/7. And since then, what we've worked out is that it don't need to be. And we'll talk a little bit more about drying rooms specifically and what you can do to mitigate that energy use. So yeah, thanks for that, Neil. It's a really good point. So like we say, there are solutions out there that work on a circuit level. They do miss the ability to leave things on and turn things off if they're all on the same circuit. And it may be that we can keep one heater on in a drying room and turn the others off if there's a low occupancy there. Something that we come across all the time is at the start of a project, we may have a period of time, 4 to 12 weeks, where there isn't any grid power or a grid connection, and a lot of sites use diesel generators or hydrogen generators or hybrid generators, and we know that the cost for running generators is huge. So Adam, I wanted to invite you in here to talk about that, and the cost of using them, and the cost of out of hours consumption. And even if you have a battery or a hybrid generator where you use a battery and the Jenny, yeah, it would be great to understand your insights around that.
Yeah, sure. Thanks, James. So, let's paint a bit of a picture here. The generator, gets spec'd to start on that site, and they don't, necessarily know exactly how much, how much power you're going to need to begin with, and no one wants to underspec anything. So inevitably, a lot of these generators end up being overspec'd for the requirements of the site. And then there's like a whole thing of, well, we want to reduce, we want to use hybrid generators, batteries to sort of reduce the effect of these. But then the batteries are, add a lot of cost. It's, people tend to go for the battery that's smallest and most cost effective. So you've got this kind of this situation that's landed here where we've got an overspec'd generator with a small battery. And then if we take into sort of account out of hours energy use, we want to use the battery during that time. And if we've got something that's in place that is controlling things on a circuit level, or at a higher level on that site, and we're not able to really turn a huge amount of it, or we can some nights but we can't other nights. We've then got this scenario where we've got a battery that's getting used up really quickly in the out of hours time, and then an overspec'd inefficient generator then coming on to replace that over in that kind of overnight or sort of out of hours time. So it's the perfect storm for high energy costs, because where we would expect sort of the diesel generator cost to be somewhere around the 50 pence per kilowatt mark, rather than the grid on like 20. That scenario breeds us having £3, £3.50, £4.20, we've seen in some scenarios, cost per kilowatt for energy that is not required to be used because it's out of hours. So it is a real challenge, and it's one that going down to that granular level and then turning more things off can eliminate. It can help in speccing those generators better, and also reduce cost in the amount of battery that's needed.
Yeah, it's a great point. It's funny that the first, say, 12 weeks of a project, if they don't manage their energy right, they could end up spending more in diesel. Let's say take a 9-month project, they could end up spending more in diesel in the first 12 weeks than they do on a grid connection for the rest of the length of the project, which is a big old issue. So yeah, I suppose what we're trying to say is look, if you reduce the out of hours consumption, you're able to run a battery for longer. You can use that, or you can use solar for longer, which is inherently going to help you with cost. So yeah, it's definitely something that we can help with. Neil, I think obviously this rings true with Woodburn School as well. Drying rooms are on 24/7. What we've worked out, and we've ran some tests with this, is if we turn a drying room off for, let's say, 3 hours in the day and 2 hours in the night, and you've got three kilowatt heaters in that drying room, the savings over a year could end up, they are huge. And if you leave that on, that cost of inaction is you're just burning energy, you're burning fuel, and you're burning money at the end of the day. So yeah, we really understand that's it's a big old issue. So yeah, like we say, core mistakes, heaters keeping them in the daytime when employees are on site. This is not necessary really. Even if you turn it off for 3 hours in the day, it's a big saving that you can make. If you're using a circuit level system, you'll have to leave them on, or all of them on, or all of them off. Whereas with us, we can have one on, turn 2 off, or vice versa, which means that, let's say that you have a drying room and it can fit 50 occupants in there, but only 10 people are working on site at that time. We could just run one heater instead of all 3, which could make some savings as well. Yeah, and on our third point, typically turn drying rooms off between 9 and 3 and 11 and 4. Some sites want to act on on caution really, and they might turn it off for a bit less. But yeah, this is absolutely fine, and we do see some savings there. So there's a couple of insights that we've come across. Another one that is a huge thing, especially in construction sites, is fires. And we know that a third of all fires on construction sites start in cabins, and this is really due to overloaded sockets. Adam, it will be good to get your thoughts on overloaded sockets, as you've done a lot of work on this and working with the data team. Can you tell us a bit about that?
Yeah, absolutely. So, sockets have a rating on them. They're 13 amps. But there are lots of appliances that use more than 13 amps for short periods of time. And that is, safe. They are able to, British plug sockets are able to take that kind of higher load for short periods of time. And it's in the normal use of that appliance. But there are dangerous levels to it. So we've seen scenarios where we've had extension leads plugged into one of our plug sockets with then heating urns plugged into the extension lead, like multiples, and we can see over 30 amps worth of draw coming through on that socket, which is dangerously high. And our sockets essentially cut off that when we see a dangerous load. So when they go above 25 amps for 60 seconds, they will automatically cut power, and that's been sort of tested to that you wouldn't catch things like a microwave going on and off, but you would catch something like two microwaves plugged into one extension lead, which is really dangerous. But we've also seen things like faulty heaters, so heaters that have malfunctioned and started, pulling more than they should, and we're able to catch them before they become dangerous. And this is the whole thing, is that in buildings, but also in site accommodation, a lot of people that come and go and aren't working there maybe permanently, might not know of the risk of plugging in an extension lead and then plugging in four things and turning them all on at the same time. They might not, we might not know in daily life exactly what that amp's going to be. So this is sort of like our kind of sort of almost better than an insurance policy. Stop the risk of a fire before it can even start to happen.
Yeah, it's a bit of an unknown truth, really, and we see it on sites all the time. People on sites are very busy. We understand that, but there is a little bit of there's not much care taken into, look, if they need something charging, they're going to charge it, whether two extension leads are plugged into one double socket or not. So this has always been a risk, and it can be potentially devastating. But really, what we're doing is, it's all good monitoring this and being able to see it. But if there's no fail safe and there's no cutoff, it's kind of, you can't have somebody sitting there just looking at it, monitoring sockets all day. So you need some sort of automation, and that's kind of what our sockets bring. If they pull too many amps for a period of time, then we cut power to the sockets. For any basic sockets, what would effectively happen is the elements inside will get hotter and hotter and hotter. And we have had this on a site, and we won't name them, we won't embarrass them, but yes, we have seen it on a site, and potentially stopped a big fire there. It's all stuff that you can see in the platform. Within Woodburn School, Neil, the site that you're on, across that project, we saw sockets overloaded and tripped about 70 times. So effectively, we've stopped fires around 70 times. It happens all the time. It's something that nobody really knows about, but we're trying to bring this to light. Okay, so we've talked about net zero. We talked about the biggest mistake with drying rooms, and we've talked about the safety policies, but something that goes along with all of this in energy and carbon reduction is how to report on it. So within our platform, we align the carbon intensity with the energy use. So when we come to turn things off and on, we can tell you how much carbon and energy you've used and how much carbon and energy you've saved. This is really, really, really useful. Another feature within our sockets is the LED light. Now, this is something that we're really trying to drive some behavioural change in. And what our sockets do is they show the carbon intensity or the cleanliness of the energy that you're receiving. So if you're on a grid, we have a programming interface with the national grid. So every 5 minutes, they send us data. We overlay that in the platform. Now, you also see it in your sockets. So if we're using more fossil fuels in the grid, they're red. If we're using more green energy, they're green. And what we're trying to teach people is if you use energy in different times of the day, now don't get me wrong, if a surveyor comes and they need to charge something up, that they've got to do it. But we're talking about leaving your laptop on in times of when you're not using it, or charging your phone and things like this. If you can shift when you use the energy, you can actually save around 7% in carbon. So what we're trying to tell people and teach people is, look, if your phone's on 30% and we're in a period of red, maybe you can wait to a period of green, because all of these little things can add up into a big picture. If you imagine across your whole workforce, you've got 5,000 workers and they all decide to use energy in better times of the day, 7% across the whole company is a big chunk of carbon. Neil, I wanted to get your thoughts on a couple of things. Obviously, within our platform, we can report on energy and carbon reduction. It shows you where the savings are being made. I know that you do some other reporting, and I wanted to talk about that. I think a lot of people use smart waste. So it'd be good to understand across your projects how you report on it, and how, I suppose, how Measurable Energy's reporting helps you as well.
Yeah, so we've now converted from smart waste to Rio, so that's still quite new. But probably the thing I would say about the whole reporting thing is maybe we wouldn't see the savings on the actual Rio platform itself. However, if you have multiple projects on Measurable Energy, for example, I think we've got 3 in Scotland at least, and then that's growing numbers. But you can then get a report from all 3 of those sites, and then I say we've got like, I don't know, maybe 60 across the UK from the other regions. Then we can see altogether how much carbon we'll be saving, and then also how much energy you're saving, how much money you're saving just by using that system.
Yeah, that's great, Adam. I wanted to ask you as well. We're starting to do some work with Kia around integrating our platform and reporting into something like smart waste. Can you just talk about integrations and I suppose the ease of them and what we're able to do?
Yeah, sure. So, the whole design of this platform is that it's, API-able into other platforms. Part of the challenge that almost every business has is the number of different platforms that you've got. So, while of course we would, love for people to log into our platform and use it, there's also not the requirement. The technology is designed to be set up, work automatically in the background, and then you can have stuff API'd, into whatever other platform you want to see, whether or not it's the energy saving, the carbon saving, what's going on with the plug sockets, the identification of the appliance, any sort of data set that we're pulling from there.
Yeah, it's really important. You want to make it as easy for customers as possible, and like you say, logging into 7 different platforms just to report on one thing. I could imagine Neil at the end of the week's probably scratching his head, going, "Oh, I've got to pull stuff in from here, pull stuff in from there." So
there's too many as it is. So
yeah,
making it a bit simpler would do much better for me and my colleagues.
Yeah. Well, any time that we can save is good, isn't it? Right. So, no, that's great, guys. The other thing that we can do, and something that we're invited to with Kia, is talking at SheOps meetings around the savings that we provide. Kia last year saved over 100,000 kilowatt hours across their sites with the use of measurable energy. And this is a really good news story. It just shows that Kia are doing their bit to try and reduce energy and carbon. This feeds into their scope 1 and 2 reduction targets. But we're always happy to go to SheOps meetings and regional meetings and talk about this and get Adam involved to talk about behavioural change. We're trying to save the world one socket at a time. A little bit cringy, but there we are. We are trying to do it, and with your help, we can do that. Okay. So, everybody, I hope you've enjoyed the webinar. These are the 3 biggest takeaways and the insights that we've found, just to remind everyone. So the hidden costs of circuit-based systems. When we talk about circuit-based systems, they don't have the flexibility to leave devices on. If you imagine you've got a CCTV system that always needs to stay on and it's on the same circuit as other things like printers and TVs that could be turned off, they're missing out on those savings. We can control devices at the device level. We can schedule off periods and on periods per device, per room, per section, or per building. It's really, really granular. It gives you that flexibility to make all the savings that you can. We talked about drying rooms, the biggest bugbear of mine. We even see drying rooms potentially that don't have dehumidifiers, and you will have heaters on with windows open directly above it, and all that heat is just going straight out the window. These are on 24/7. What we found out is that you don't need to run for 24 hours of the day. You can still dry clothes without running them for 24 hours. So yeah, something to take away and talk to your site teams about. And the fire risk lurking inside cabins, it's not just inside cabins, it's anywhere where there's plug low power. But we do see it on construction sites because everybody's so busy and all they want to do is get their job done. But that is fine as long as you've got some sort of safety measure or something automated that can stop a potential fire risk. As I mentioned, any basic sockets, the heating, the elements within the socket would become hotter. We've had it before where sparks have flown out of a basic socket. We've done testing on it. We mitigate that. We cut the socket if there's too much power being drawn. Okay, I can see some questions in the chat. So let's bring it up. All right. Okay. We've got a question from Jamie, Adam. This might be a good one for you. If stage 5 overspec generator is used, when load comes down overnight and generator is running out of its efficiency band causing damage. Ooh, what's this?
Yeah, so this is yes, Jamie, this is exactly what is happening on a lot of sites. We have, an overspec generator. It's a very, very small battery. Battery's getting used up very, very quickly, and then there is damage to the generator. There's damage as well as high energy costs. And this is sort of the whole point here. If overnight load is reduced enough so that it fits within that battery, then we reduce the need for that generator to kick in. It's difficult because it does every site's slightly different. So there's almost a need to sort of spec generators out to begin with and maybe reevaluate as the site's up and running to optimize that. But yeah, you've hit the nail on the head that damage is literally happening, and we're saying that this is a way to sort of start preventing it.
Thank you, Adam. Jamie, do pipe up if you've got any follow-up questions to that. Hello, Kai. Hello. Thanks for your question. Another one for you, Adam, around baselining and how we justify our savings. We've got lots of stuff on the website, but yeah, please do talk about that.
Sure. Okay, so how we justify savings. So we don't use baselining. And we don't use it for a number of reasons, and that is that having, there are so many variables in a building from one period to another that it becomes very, very difficult to even justify that your savings are real, from comparing, say, 1 month to another month, or comparing another building to one building to another building. There's different levels of occupants in the site, different numbers of people working there, different appliances, can have different weather, different sort of seasonal patterns. There's all of these differences then make it really, really difficult to then accurately be able to go, well, we from this month to that month, we think we've got a reduction there, and then sometimes it's an increase. So the way that we do it is we use some AI in our sockets that basically learns the pattern um, of what gets plugged in when and where. So we identify what appliance it is. So it's a monitor, it's a laptop, it's a printer, and then we identify or learn the state of that device. So by state, I mean how much energy does it use when it's in standby? How much energy does it use when it's in active use? How many standby modes does it have? How many active energy use modes? Because some devices have lots of different ones. And then we learn the pattern of that, and the kind of the behavior of that appliance. And what I mean by that is that if you're sat at a desk and you take your laptop away and there's a monitor there, when that monitor is no longer now in use and it goes into standby, or is no longer in use, how long does it take to go into standby? And what is that standby mode? And does it go into multiple standby modes? Same with like a TV in a meeting room. When someone leaves it, how long does it take for it to go into a standby mode? And when we combine those three things, so the appliance, the states that it's got, and the behavior from it, we can then accurately project over the overnight period or the off period how much energy it would have used if it was off. And then we can line that back up with the energy bills that are being used at that or come out of that building. So whether or not that's diesel bills or whether or not that's a grid bill.
Great, thank you, Adam. Okay, any more questions from anybody else? Dean, thanks for that. Yeah, on the connectivity side, Wi-Fi only. Yes, that's right. We're a Wi-Fi, we're an IoT device. We connect to the existing Wi-Fi in the building or site accommodation. We run on 2.4 gigahertz. And now we're getting a bit technical around LoRaWAN option. We had this question earlier in the week, Adam, and I came straight to you.
Yeah, no, we don't have a LoRaWAN option. Our kind of So our philosophy has always been to try and reduce as much cost as possible. So Wi-Fi is in almost every single building. There's it is getting developed. It's got lots of iterations to it. It's a technology that's only kind of growing. We spent a lot of time at the beginning to sort of going into a lot of detail on the security. You mentioned 2.4 there. Absolutely. We later on this year we have a 5 gigahertz version of our socket coming out, so we'll be able to support 2.4 and 5, and people will be able to choose how they want to set that up on their network.
Yeah, Dean, I suppose the good thing about our sockets is the amount of data that they use is really, really small. If you compare it to the meeting that we're on now, and we've probably done 4 or 5 gig, but our sockets, I think the max we do is around 50 meg a day. So we don't see networks falling over because of the use of our sockets. Casper, what is the heuristic load of the sockets? How does this compare to, say? Go on,
yeah, so this is it is super tiny. So each socket uses less than 0.2 of a watt. And it is factored into the calculations for savings. So it's factored that we are using that amount of energy, and when we report on savings, we've accounted for that 0.2. A mesh network. So they at the moment for security reasons, we don't use a mesh network. So each socket is individually pointed up to our cloud. They're air gapped from other sockets, meaning that if for any reason or that anything was ever compromised, there's no route into anything else. But they can be connected up through a router, so they can be on a 4G or a 5G router. And then integration there. So yeah, they essentially the data that comes up to our cloud can within reason be API'd into almost any system that you want it to. It just needs to we just need to you just need to know or have it set up with the API with to be able to take that data in.
Great, thank you, Adam. We'll give it another minute if anybody else has any questions. Whilst we wait, we'll do a bit of a wrap up. So we're happy to answer any questions or go through things in a lot more detail if you want to jump on a call with us or join you on a site and do a survey. More than happy to do that. Do reach out to me. Thank you, Sarah. Just dropping my email in there. I'll get back to you today with that. But like we say, we've gone through our biggest takeaways. Hope that this has helped. Like I say, we'd love to hear from you, but what we're really trying to do here is create a solution that is as cost effective as possible, that reduces out of hours consumption, that pays back within the project length, and really saves you money in carbon. Neil, I've seen you come off mute. Thanks so much for your time. Is there any parting words you'd like to say?
You're just saying about the kind of the buyback stuff. So I would say, like, what I didn't say before was that Woodburn had a buyback period, I think about 4 months for an 18-month project. So it means that once you've been on the measurable energy grid for 4 months, you're already making money after that. And then after that, we were able to then take the same socket appliances and then put it on a different project, which means that that project is already starting to save straight away without any upfront costs.
Yeah, it's a great point. Thank you, Neil, keeping us honest, bringing that up, because it's something that I forgot. Yeah, it's like we say, if we can save you as much and as quick as possible. Oh, Dave, good question. What's the fastest payout we've ever had? 21 days. And when we talked about it, this was on a generator as well. I think it was about 5 appliances. Around 15 of those were heating elements. The rest were double wall sockets, controlling stuff like TVs, monitors, and printers. But yeah, 21 days. I say the client was very happy with that. And like Neil was just mentioned, after those 21 days, any savings that you make are yours then, and that's I think that's huge, and that can really make a difference on a project.
Yeah, Woodburn wasn't even it wasn't even a huge project, but I think it was still 47% reduction in energy use, 34% reduction in carbon along those lines. So it'll be good to see when we get to bigger projects with like more heating rooms and more drying rooms, whatever, more fuse spurs. Then you hope that number will go up.
Yeah, Woodburn only had 22 appliances, so like you say, the bigger the site, the bigger the savings. Yeah, great.
Yep.
Okay, right. Well, let's stick to time. Thank you for your questions, guys. Neil, pleasure as always. Thank you for your time. Adam, couldn't have been here without you and all your technical knowledge, so thank you again. Yes, do reach out if you'd like to know more, but thanks for your time and enjoy the rest of your days.
Cheers.
All the best.
Thanks, James.
Yeah.
Cheers.